The first step in any kind of question answering is answer type detection and query formulation. So going back to our box diagram here, our flow chart, we have a question, and the first thing we're going to do in question processing is understand what's being asked here. There are as many as 5 things that we normally extract from a question. Perhaps the most important is the answer type. This is a named entity, a person or a place or a date, that tells us what we're looking for in this factoid question. Query formulation, equally important. That's the set of words we're going to send to the IR engine that tells us what to look for, what passages are likely to have the answer. And then other kinds of things, depending on the system, may also be extracted. So question type classification, we want to know, for example, is this a definition question? We might have to find a definition in a dictionary or build one ourselves. Is it a math question? We might want to answer that with mathematics directly rather than going to find text snippets. Or a list question, we're looking for lists of things, so we might want to look for list sources. And there are other kinds of things like focus detection, so find the question words that are being replaced by the answer, or relation extraction, find all the relations between entities in the question. We talked about relation extraction earlier, and these are used by some systems and not by others. So here's an example of the kind of things we might extract from a question. This is from a Jeopardy kind of question. So there are the 2 states you could be re-entering if you're crossing Florida's northern border. So here we're looking for a state, a US state, so the answer type is a state. What we might want to send to the IR engine is 2 states, border, Florida, and north. These words are going to be good words to find passages that might have the answer. The focus, the thing that we're trying to answer, is 2 states. And the relations that we might extract, the relations that express what the answer is the answer is some unknown thing which is in the borders relation with Florida and north. So something that's north of Florida. So if we have databases that express geographical information like what state borders what state, we might look for this relation in those databases. So the first step, answer type detection, here we just need named entities. So if I see a question like who founded Virgin Airlines, the answer type is person. If I see a question like what Canadian city has the largest population, the answer is a city. Relatively simple. And for that, we need an answer type taxonomy, or a type of named entities that might be useful in question answering. So for example, here's the taxonomy from Lee and Roth. They talked about 6 course classes. We might ask about abbreviations or entities, descriptions of entities, people, places, and numbers. These are the kind of things we might have. And inside those, we might have more specific classes. So we might be asking about a city or a country or a mountain as a type of location. Or we could be asking about a person or a group of people, and we could be asking about all sorts of different kinds of entities. And here's their answer type taxonomy, showing some of the individual subtypes of the major 6 entity types. So a numeric question could be a date question, or a distance question, or a percent question, and so on. Any of these kind of types we might want to find. And here's just showing you, it's in small font, so you can come back and look at it later, but the kind of answer types that are in the Lee and Roth taxonomy. So we might have currencies, or diseases, or foods, or instruments, and so on, and some examples of each of these. Or for locations, we might have mountains or states, and all sorts of things for numbers, speeds and sizes and temperatures, and so on. The Jeopardy system also used a lot of answer types, and they did a nice analysis looking at 2,500 answer types inside 20,000 questions. And what they found was that the most frequent 200 answer types covers less than half of the data. Here's the 40 most frequent Jeopardy answer types. So you can see in Jeopardy, you tend to be asking about people or movies or countries or cities and so on. Here's more people, authors, and so on. But still, there's a pretty broad distribution of possible answer types. So we're going to need a large number of answer type detectors to really get a large set of questions for something like Jeopardy, or even for easier factoid questions. How do we do answer type detection? Like almost everything we've seen so far, we can do handwritten rules, we can do machine learning, or we can do hybrids of the two. And we're going to see all 3 of these in modern systems. So for example, for some kinds of answers, we might do very well with regular expression rules. So if we see who, and then a form of to be, and then a named entity person, then our guess is that we're asking, this is a person question. or if we see in an answer person and then year dash year, we know that this is that we're looking here for a person. In other kind of rules, we're going to be using the question head word, and the head word is generally the head of the first noun phrase after the WH word. So here we have WH word which, and then the head word is city, or here we have a WH word what, and here's the noun phrase, the state flower of California, and its head is flower. So this head word often will tell us a lot about the answer type. This tells us that we're looking for city, and this tells us we're looking for a flower. But more often, rather than simply writing handwritten rules, we treat the problem as machine learning. So we define a taxonomy of question types. We've seen some already. We annotate training data for each question type, and now we'll train classifiers using some rich set of features, which might include those handwritten rules we've talked about, to decide what question type a question is. What's the answer type of a particular question? And the features we're going to use for these answer types, the words or phrases in the answer, the parts of speech tag, we might use the head words we talked about, named entities, semantically related words, and all of these kind of regular expressions we can handwrite for particular question patterns. The next step in factoid QA, we've done answer type detection. The next step is query formulation. How do we decide what words to send to the IR engine to return documents and then passages? And one well-known keyword selection algorithm from Moldovan et al. Uses a number of heuristics, each of which tell you which keywords in the question might be important keywords to put in the query. So if we see words in quotations, that's a very likely word that people are looking for. And another important thing to look for is proper names, and then other kinds of nominals, and maybe less important verbs, and then even less important adverbs, and maybe all other words might be even less important. So we have a ranking of what words are important to put in the query. So for example, here's a slide from Mihai Serdeanu. So we have a question like, who coined the term cyberspace in his novel Neuromancer? Well, we might throw out some stop words, so who and the and in and his, and now we might say, well, cyberspace and Neuromancer are in quotes. Those are probably things we definitely want to be putting in the query. Term and novel are nominals, and we saw nominals are an important thing. We ranked them as ranked 4. And now a verb might be rank 7. So we might say, extract from this that we have 2 terms that are extremely likely to want to be in the query, and something that's a little less likely, a couple less likely things, and even less likely. So now we can form the query in various ways. We could try just sending the things of rank 1, or we could send go until we have enough query words to make a long query, or we can send things of rank 1, see how many queries we get back, and if there's not enough, add in more query terms, and so on. So what we do with these ranking of queries depends on exactly what database we're querying, whether it's the web or a smaller database, and so on. So we've seen the first step in factoid-based, IR-based factoid question answering, which is extracting an answer type from the question and extracting the query terms that we're going to send to the IR engine.